Hello Year 12s. This is the recurrence relations question 3 from the desmos lesson. Right, so here's our recurrence relation. We've got the homogeneous part here and then the non-homogeneous part there. So the homogeneous part gives us our complementary function. Okay. You don't need to write that out. I'm writing that to try and help you see that the complementary function is just a guess for the closed form. Okay, so complementary function. This 3 times the previous term tells us that we're multiplying by 3 every term, so we're going to have powers of 3. But we don't know where we start, so we put times some arbitrary constant that we'll find out later. Okay, now we turn our attention to the non-homogeneous part here. So we've got a power of 2. So that means that our particular solution is going to take the form of a power of 2, but we don't know what multiple of the power of 2, so we do a times the power of 2. Remember that that one there has just got like an invisible 1 next to it, and we're replacing that constant 1 with an unknown constant. So then this is our guess for a closed form that should work. So we're going to test it out. We're going to pop it into the recursive formula and see what value of a makes it work. So we need the n plus 1th term as well. So that would just be a times 2 to the n plus 1. Right, let's pop it in. So we've got on the left the n plus 1th term, and on the right 3 times the nth term plus 2 to the n. Okay, let's write it all in terms of 2 to the n. Now we can compare coefficients of 2 to the n. So on the left hand side we're going to have 2a, on the right hand side we've got 3a plus another 1, and then we can solve that to give us a is minus 1. So that means that our particular solution is minus 2 to the n. So now we have a complementary function, particular solution. This works for this part of the formula, this works for the whole thing, especially that particular bit, so we combine the two. Okay, so our general solution is that the closed form, the nth term formula, is arbitrary constant times 3 to the n minus 2 to the n. And to find that arbitrary constant, we're going to use our initial conditions. So when n is 1, u1 is 8, so we substitute that into our general solution. Okay, and we solve that for a. So we've got 10 is 3a, and so that means that a is 10/3, which then we pop it in to the general solution to give us our final solution. Okay, so the closed form will be 10/3 times 3 to the n minus 2 to the n. You can leave it like that, or just to make it a bit prettier, let's get rid of the fraction. So we've got 10 times 3 to the n minus 1 minus 2 to the n. Okay, let's just make sure that is definitely correct. So on the calculator, we're in the recursive menu. So just to remind you, that's menu 8. Okay, now we need to pop in our recurrence relation from the beginning. So an plus 1 is going to be 3 times an plus 2 to the power of n. And now we're going to put in our closed form here, our solution. Now this is for n, this is for n plus 1, so we're going to have to replace all the n's with n plus 1. So we've got 10 times 3 to the power of, that will be n, minus 2 to the power of n plus 1. Okay, we press set. We're starting our counter this time at 1, and our first term is going to be 8. Okay, at 8. Right, so let's check. That's it. So the sequence from the recurrence relation in the question matches the sequence for the closed form in our solution.